Here we go with lesson 5.3, solving trig equations. Now instead of verifying identities, we're going to solve equations. And if you'll look with me, example 1, it says, we're on page 365, we are going to solve 2 sine x minus 1. 2 sine x minus 1 is equal to 0. So whereas twice the sine of the angle minus 1 equal to 0. Well, we're going to use regular algebra. That's great. It's going to come in handy here. We're going to solve this equation just as we would an algebraic equation by adding 1 to both sides. And 2 sine x is equal to 1. Any coefficient to the function, we're going to divide by that. And what we're asking is, where is the sine of x equal to 1/2? And so once again, our handy-dandy unit circle, where's the sine equal to 1/2? Well, we can see that that is pi over 6, and we're looking for the y value, 5 pi over 6. Well, the lesson goes into this. Are those the only two answers? We understand that because sine is cyclic, going on and on and on indefinitely, it completes a period within 2 pi, but what we're asking is, where's the value of this function 1/2? And if we think about the graph of the function, we can look at it like this. Sine starts at 0, comes up, maxes at pi halves, comes back down through 0 at pi, finds its greatest minimum at 3 pi halves, and completes its cycle at 2 pi. So what we're looking for are these values where it is positive 1/2. And we know if we take this down to here, we're going to find the value pi over 6 in our domain, and we're going to find 5 pi over 6 as well. However, we're going to find it again and again as sine keeps completing, so we can say that x is equal to pi over 6 plus 2 pi and every cycle of that, so 2n pi. We can also say x equals 5 pi over 6 plus 2 pi, or 2n pi's, every rotation or cycle through 2 pi. So we can think about this in terms of our unit circle. Where does it happen? That also relates directly to the graph. Where is the sine value 1/2? And we see pi 6 and 5 pi 6. You guys try number 29 and come back and check your answers. Well, we're going to use that same algebra. We're going to subtract 1 this time, and we're going to divide by 2 again. You can see we're going to get something very similar. Where is the sine of x equal to negative 1/2 by the time we complete all of our algebra? We're going to look at the unit circle. Sine is negative 1/2. If we enlarge that, we can see that sine is negative. Let's go down here. Sine is negative in the 3rd and 4th quadrant, and we can see that the sine is negative 1/2 at 7 pi over 6, and we can see it is negative 1/2 at 11 pi over 6. So similarly, we're going to say 7 pi over 6 plus 2 pi, or 2n pi, every rotation thereof, and we can say 11 pi over 6 plus 2 pi, or 2n pi, every time we go around 2 pi. So you can see example 2, I've blown up the unit circle a little big. We're on example 2 on page 366, if you want to follow along, page 366. So we're going to solve this one again. It says find the solutions, but this time in the interval 0 to 2 pi. Remember that square bracket means including 0, and that rounded bracket means up to 2 pi, but not including 2 pi. So we're going to go ahead and solve this using our algebra. Once again, we are going to add the sine of x to both sides. Same, both sides of the equation, sine of x, and we're going to subtract the square root of 2. Subtracting square root of 2. So these guys canceled. Over here I get 2 sine of x. Twice the sine of some angle is equal to negative square root of 2. We want to get rid of that 2. We're going to divide both sides. So we're looking for the angle where the sine is negative. Square root of 2 over 2, you guys should recognize this as 45 degrees. So let's look at our unit circle. The sine is negative in the third and fourth. So we can see here at 5 pi over 4, and here we have negative square root of 2 at 7 pi over 4. So because we are within this interval, we have 5 pi over 4 and 7 pi over 4. And those are the only two answers this time. We're not looking for all angles. We're looking for the 2 within the interval. This is example 2. Go ahead and try problem number 37 and come back and check your work. So we've got tangent this time. The tangent of x, square root of 3. We know we're going to use our algebra skills, square root of 3. We're looking for the angle whose tangent is negative square root of 3. Recall tangent is sine x over cosine x. So we're going to be looking at our unit circle and trying to figure out where we get a simplification of negative square root of 3. So sine over cosine is negative in the second. We can be in the second quadrant, or we can be in the fourth quadrant. So which of those, sine over cosine, are going to simplify to negative square root of 3? Well, we've got, let's look at 2 pi over 3. Let's look at square root of 3 over negative 1/2. Tangent is sine over cosine. So the square root of 3 over 2 divided by negative 1/2, that means multiplied by negative 2 over 1, that would simplify to negative square root of 3. So we're looking at 2 pi thirds. Similarly, it's going to happen down here where we have negative square root of 3 and over 2 and 1/2. So again, we have negative square root of 3 over 2, which is the sine of 5 pi over 3, divided by 1/2, or multiplied by 2. Again, we get negative square root of 3. So our second angle, 5 pi over 3, that is the angle whose tangent is negative square root of 3. So example 3 says we're going to use the fact that we can extract square roots. We're going to solve 3 tangent squared x minus 1. First step, we're going to add or subtract. So we get 3 tangent squared x is equal to 1. We're going to divide by 3. We get tangent squared x is equal to 1/3, and we want to find tangent. So we end up with tangent x is equal to 1 over the square root of 3. We've got to radicalize that denominator, multiplying top and bottom by square root of 3. We get square root of 3 over 3. So we're looking for the angle whose tangent is positive. Now we're positive, square root of 3 over 3. So tangent is positive in the first quadrant, and it's going to be positive in the third quadrant. So we're looking at both of those spots to find our answer. Square root of 3 over 3. So last time we simplified to the square root of 3. This time we want square root of 3 over 3. So I have got to say we need to be looking right here. Let's try this. The sine of pi over 6 is 1/2 sine over the cosine. So we're going to simplify that to 1/2 times the reciprocal 2 over the square root of 3. We get 1 over square root of 3, which is what we had up here, which simplifies to square root of 3 over 3. So we do know that one of our angles is pi over 6. So let's look in quadrant 3. Don't need that. Quadrant 3, and we're looking for square root of 3 over 2 and 1/2. We see that square root of 3 over 2 and 1/2, except this time they're both negative. So we can see that pi over 6 and 7 pi over 6 would be our two angles. Notice that they are pi apart. From 1 pi over 6 to 7 pi over 6, they have a difference of pi units. So that is example 3. After example 3, let's try number 39 and come back and check your answer. So in problem 39, it asks you to solve, I'm missing something here, equals 0. So again, we're going to pull out our tool belt, get to work. Cosecant squared of some angle x is going to equal 2. We're going to take the square root of both sides. And the cosecant of x is going to equal the square root of 2. We know cosecant to be 1 over sine is equal to the square root of 2. So sine is going to equal 1 over the square root of 2, which is square root of 2 over 2. So we're looking for the sine of x. Sorry about that, I get in a hurry. The sine of some angle that is the square root of 2 over 2. So if you guys think about your unit circle, I bet you do very often, every day. I'm sure that's going on. We're looking for the sine of some angle, the y value, to be the square root of 2 over 2. And we can see that right here, the sine of pi over 4 is the square root of 2 over 2. And we can see that the sine of 3 pi over 4 is also the square root of 2 over 2. So we have pi over 4, pi over 4, and 3 pi over 4. And those would be our two solutions for that. And I'd like you to notice now 1 pi and 3 pi they have a difference of 2 pi over 4, or pi halves. So we found the sine, whose sine is square root of 2 over 2, 45 degrees, and plus 90, 135. And so example 4 at the top of page 367, it gives us a hint. If we have trig functions on both sides of the equation, we want to gather them on one side. So they're going to go ahead and subtract 2 cotangent x. So we've got cotangent x cosine squared minus 2 cotangent x, setting that equal to 0. And we can see that we can factor out cotangent x. Each term has a cotangent x, leaving cosine squared minus 2. And setting that equal to 0. Now, because we have combined functions, there could be something that does not have a solution. So when we break this apart, we know the zero products property. If two things multiply together and have a product of 0, then each of them has the potential to equal 0. So we're going to set these both equal to 0. We're going to add 2 to both sides, and we're going to get equals 2 On this guy, we're going to take the square root. So the cosine of x is equal to